Hey, this is Dan Shirley with Weasel Racing. Today I'm just gonna kind of do a air conditioning 101 for folks. This is just a topic of interest of mine. Figured I'd do this while I'm procrastinating putting off welding. Just kind of go through the components of an air conditioning system in a car. This is an older 2005 Subaru. This is just an Impreza, but I'm putting in an engine out of a Legacy, so things will look a little different if you have just a regular 2.5 liter. This is a 3 liter. So some of the components like the compressor and everything here are different. So that's why it looks a bit different. But I just want to kind of run through the parts here, the components and what they're doing. And just to give you an idea of kind of my background, I am a data scientist specializing in industrial and commercial HVAC, so mainly with data centers. Huge systems though, where this tiny adorable little compressor here is really neat, but the systems I deal with upwards of like 2,000 tons per compressor, so much larger systems than this. I'm not a technician, I am a data scientist though, so everything I'm going to talk to is from a sort of state of matter and physics perspective. But I figured I'd start here with the compressor and kind of walk you through what we're looking at. So the compressor on this car, this wheel's a bit smaller than the 2.5. I think that's probably because this engine spins a lot faster. So the wheel doesn't need to be quite as big. This compressor though, its main purpose is to take in the gaseous refrigerant from the evaporator that I'll show you in a minute. It comes into this port here through this. This is the suction line. This line is not going to work. I'm going to wind up having to replace this with the one from the actual H6 engine. You can see it's not even remotely close to the right orientation. But I pull in my gaseous refrigerant into here, and then I am compressing it to a much higher pressure. This is R134A, by the way. It's coming out then on this discharge line. It runs down this line into the condenser. So this piece here, this is, I think people probably think that this is the radiator. The radiator is actually back there behind the condenser. The purpose of the condenser is to take in high pressure gas, and then it's going to pass through the coils here. It gets a huge surface area increase because of all these tiny little fins, but the refrigerant is actually in these tiny tubes here. It passes through the condenser, also goes through this piece here, which is called the dryer, which is meant to remove any, basically water. It's going to remove any condensation that might have gotten into the refrigerant that can happen, especially after the cistern's been opened. The dryer's purpose is to get the water out of there. That will really cause a problem. It won't be able to condense and evaporate properly. And then it will leave the condenser at this point in a liquid state. It should be leaving in a liquid state. It's going to pass out of this line right here and go into our liquid line, which right now I got to figure this out. This is a race car, so things don't really look like they're going to, but back here is my liquid line. I have my pressure switch. Purpose of this is basically to make sure that I am actually leaving in a liquid state. And if my temperature or pressure is getting off here, this right now is just a pressure switch. I think this engine actually needs a temperature and pressure switch. But we're making sure it leaves in a liquid state. If it weren't doing that, then we are not pressurizing enough, and it's going to basically dictate what the compressor is actually going to be doing. Leaving that station, passing back through here, it goes into the firewall back there. And then it comes into probably the most important part of this whole system. This is, I don't actually know what Subaru would call this, but this is called an expansion valve in the industry. It's coming into this in this bottom port here. The liquid comes through there. This basically has a thermostat. So it's probably this bulb up top here that you can see there's a spring in the bottom of the expansion valve right in there. But this bulb up here typically is probably what's making this thing actually move up and down. Liquid comes through this, and then as it passes through the expansion valve, this is basically metering the liquid flow rate into my evaporator. So again, liquid comes in here, goes up into this part here, passes down through this, so you can see that the coils are oriented the other way. And that's going to leave this thing in a gas form. So it has evaporated in here In doing so, it is then basically absorbing a bunch of energy as the air in the cabin is passing through this. That's what makes it go from a liquid to a gas. And then I am coming back out of this big tube. I come through the top of the expansion valve here, which again is just basically making sure that the liquid rate is matching the temperature. So if it were to, like, let's say it gets much hotter, the gas coming out of the evaporator is getting hot, it would open itself up further and allow more liquid in, effectively is what's happening here. And then we come back into the suction line, which is here, and we go right back into the compressor, and around we go. Important notes on this: there are sensors throughout the system. This isn't very complicated though. Generally, there's a sensor right here in the evaporator that's measuring the temperature at the evaporator, make sure it doesn't get too cold and freeze itself. The ECU would interrupt it if it were to do that. And then I have a couple sensors here. This is different than a 2.5 from the older cars. This is called a lockup sensor, which is actually really difficult to figure out what Subaru is doing with this, but effectively the purpose of this is to see if the compressor, like, there's a couple different states here. If the compressor is starting to lock up, it could be because of refrigerant stacking, so there's liquid kind of coming back up, stacking up at the expansion valve and coming back into the compressor. If that liquid were to hit this compressor wheel, it can really damage it, and honestly, it can probably cause damage to the engine if this were to lock up at that point. So this sensor will check to see if this is spinning the same rate, the clutch is spinning the same rate as the wheel, and if it weren't doing that, it would release the clutch to protect the engine and protect the compressor. And then this little wire here, this is actually the signal that locks up the clutch. So this thing's pretty straightforward. The older Subaru engine has that too, so that's not complicated. And then, like I told you before, the pressure temperature switch, depending on the year of the car, is down there. And again, that switches the compressor in and out depending on the pressure down there. Just if it gets really high, it's going to back off or release the clutch and stop spinning the compressor until the pressure drops again. So yeah, this is a race car, so it's a bit of a mess. There's a lot going on in here, but that is more or less a refrigerant circuit in this car, and I now need to just figure out how to make the pieces work, because these lines aren't the same. I need to get like this suction line reoriented and things, so I'll probably take one out of a junkyard car or something. And now I got to figure out a jumper from this down here, which is where the old condenser used to have its connection, to where this condenser has it. I'm using this condenser out of the 2008 because it's a bit smaller and easier to push forward. The whole thing had to be moved because of the aluminum rad, and the engine's bigger and everything, so everything had to come forward. But it's, I don't know, we'll find out how hard that's going to be. It might just be fabricating a line to get myself up to this point. So yeah, that I think covers all of the components. So I doubt many people watch this, but if you did, I hope you enjoyed. See ya.